Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of solving scale problems. This is Standard 7.5C in the great state of Texas, and we are using item number 19 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we've got two different triangles here. We can tell they kind of look similar, but the problem tells us specifically they are similar, which means two things. So the sides are proportional, which we are going to be able to use to solve the problem. And we also know the angles not necessarily are proportional, but they are congruent. So similar triangles have proportional sides, have congruent angles, but we don't really need to worry about the angle measures here. We're trying to find the length of RU, so that's this guy right there. So since we know that the sides are proportional, because the triangles are similar, we can set up a proportion. Many different proportions we can set up. So let's set up a few, because I'll show you that as long as you follow some basic rules, you can really choose from any proportion you want to. So RU maps to this KM. Okay, so let's put those two together. So let's put them in a proportion, right? So I'm going to say Km, which is really, right, 14 centimeters. But I'm going to put that, the sides right there, that name Km, just so I can kind of keep that in the back of my mind, is to Ru, which is unknown. So I'm going to just say that's X, right? So we're looking for X. Now, since I've got the side of the larger triangle, I need to find another side of the larger triangle. So let's say this KL, which is 10 centimeters. And so since I did the larger triangle as the numerator, right, I need the corresponding smaller smaller triangle side. So it would be this RT. You notice the orientation is the same, so I can say RT, and that's 2.5 centimeters. Right, so since this is proportional, we can use cross multiplication here, and now I'm just going to use the 14. 14 times 2.5 equals 10x. Well, let's see, 14 times 2, I can actually split it up if I want to, right? Plus 14 times a half, it's going to equal my 10x. So that's going to be 28 plus half of 14 is 7. So that's going to be 35 equals 10x. Divide both of those by 10, I get 3.5 equals x, which looks like that 3.5 right there. Now, what if I didn't want to set those up? Well, there's, like I said, many different proportions you can set up. What you can do is, now we are going to need km, like regardless of what we do, but let's do this. Let's do the bottom side, lm, 12 centimeters, to km, 14. So so I'm going to have my proportion be of the same triangle to the same triangle. Km equals, now I need to do the matching on the other triangles. So I had Km, so I had my, actually this is my Lm on top, my Km on the bottom, right? So my Lm matches to my Tu, so that's going to be 3. And then I'm going to have my Ru, which matches to the Km on the bottom. So that's going to be, I'll call that X, Ru, okay? So we could do cross multiplication, or we can say, hey, look, if I need to go from 12 to 3, that's divided by 4, right? Now, 14 divided by 4 doesn't go in evenly, but we can at least do 4 goes into 14, right? And that's going to be 3, and obviously you know where this is going, right? It's the same proportion. But we can go and just bring this down. It's going to be that 3.5. So you can set up a proportion between triangles, within triangles, as long as you map the correct side of the correct side. Obviously, we could do this multiple different ways. We're going to still end up with that same answer of 3.5 or D, 3.5.